we never got into solving circuit problems. We only got into what is a parallel circuit, what is a series circuit. So I wanted to introduce you to something called a VIR diagram. This really helps you figure out what's given and what's missing that you can solve. So this was the stuff that I introduced to you last class. In fact, let me get to the previous slide because it's a little bit bigger. So we've got our vertical circuit, which is always helpful. We've got our parallel circuit, which branches off into two separate branches. The fact that the series circuit only has one wire means that the current stays the same. And the fact that the parallel circuit, the voltage is connected to both resistors mean that the voltage drop is the same. So the voltage stays the same and the current stays the same. The equation for resistance is different for each. That's in your physics helper. And using up the cover-up method to solve your problems. If you're solving for resistance, it's V divided by R. If you're solving for current, it's V divided by I. And if you're solving for current, it's V divided by R. And then solving for voltage, obviously, R times I, resistance times current. So that method is super helpful, along with the VIR chart. So we found in first period that the concept builder homework is more difficult than the worksheet. So I'm going to work through one problem for each concept builder homework, and then you're going to work on that for the remainder of class. During that time, I want you to start talking to people and see what groups you want to work in. But as I stated, I'm going to work through one concept builder each. I've actually dropped most of worksheet 3. I just want you to work on problems 6 and 7 if you get done with the concept builders early. And that means that all you have to do is do some reading homework and that keep up with those worksheets. Okay, so if you want to, actually you can even use the back of your warm-up. If you want to take notes on each concept builder, it'll help you for sure. So we're going to start with series, and you only have to do the wizard level. I had students get a health score of 0%. Don't worry about your health score because I like to keep checking my answers over and over again. And each of these rows that you're going to see here are a separate problem each. So we're going to start with wizard level. I'm just going to do the top row for you, but I'm going to walk you through an example of how to do this using vertical circuits and how to do this using the VIR chart. A series circuit is one wire all the way down. I always start with a positive on top, which is the longer line. Notice how our battery has long, short, long, short, long, short. The long, short is the positive, negative. If you have 3 in a row, that means you have 3 batteries in a row. So our total voltage, we're looking at row 1, is going to be 12 volts. And I always write that on top. And then my resistor 1 and 2, R1 is equal to 2, and R2 is equal to 4. And that's in ohms. Is that all they give me? Okay, this is where having a VIR chart is really valuable. So, in a VIR chart, you always have an empty space for your kind of title column and row. You always write VIR along the top. You could do it the other way too. I've seen it done that way, but this is how I do it. And then you have resistor 1 and 2. And then the bottom column, or the bottom row needs to be the total. So, your total voltage is the total of your battery. I'm going to fill that in 12 volts. Your resistance that's given is in the resistance column for 1, and then the resistance column for 2. By doing this VIR chart, you can look for rows or columns that have any missing pieces. And so the most obvious one is right here. I have R1, R2, and I can solve for the total. If we look at my slide, for series circuits, the equation for total resistance is just taking the sum of all the resistors. So what's my total resistance here? It's what? 6. Now you've got an opening here. And this is where my triangle cover-up method is super helpful. Because now I'm solving for current, and my current is voltage divided by resistance. 12 divided by 6 is 2. What can I do now? I don't have any more columns or rows that I can fill in because it doesn't have a missing piece. But there's something about series circuits that you need to remember. Any thoughts? What do you think, Sin?
I don't know if I'm right, but should the same?
Very good. I only have one wire. I've calculated that the current total, which is the current coming out of the battery, is 2, but I only have one direction and one wire for my current to travel, so it's going to be 2 all the way across. So this is only for series, but it's going to be 2 all the way across. And now that we're solving for voltage, I times R. Easy peasy. This is 4, and this is 8. Once you've got all this filled out, you go right back into your circuit series. Your equivalent was 6. You have to use this little pad, which is frustrating. Current we established is the same, so it's going to be 2 all the way across. And then the potential difference. 2 is right here. Sorry, B is right here. And I started off with a total of 12 volts. I established that my voltage drop is going to be through resistor 1 is going to have a voltage drop of 4 volts. And when I say drop, I mean it's going to decrease in voltage. So if I started off with 12, I decreased by a voltage of 4. What is my voltage drop or my potential difference at B? It's going to be 8. It's whatever's left over anytime you go through a resistor. So 8 is going to be my answer. And then you can start filling out the other stuff, and it's going to dock you in your health points, but I don't care. I don't care about your health. I care about you completing the level. So I do care about your health, but I don't care about your health score. So if you get your green all the way across, you're good. B, this row is a totally different problem. Students were trying to connect A to B and then to C, but B is, notice how the battery is going to change, the resistors are going to change, so that means that you're going to have to erase your entire VIR chart. You're going to have to erase everything that you had set up here, and then you're going to have to fill it in with these new values. Okay? I'm going to do parallel on a new whiteboard because students wanted to see it while they were working on this. Are there any questions? Obviously, as you're working on it, I'll come around and help you. But let's do parallel. Parallel is the harder one of the two. Not as many problems, but definitely harder. Okay, parallel circuit. Make sure you log in. And again, it's the wizard level. Okay, the setup for this one is tricky. And I want you to pay attention closely. I'm starting off at the positive side of my battery. I travel through A and I branch off through B and C, which is then connected to D. So it's going to look like this. Here is resistor 1. It branches off into resistor 2, which then connects back to the battery. The reason why I have to make sure that B and C are to the right of my connector is because these symbols, A, B, C, D, and E, are at very specific points. A is right out of the battery. B is right above resistor 1. Here's C, here's D, and E is right here. This was where a lot of students messed up. And again, we're going to do a VIR chart. VIR, 1, 2, 3, and a total. Let's fill in the information that's given. Battery is 12, resistor 2 is 2, and the current through A is 12, current through D is 4. So I've got 12 here. I've got resistor 2, so that's 2 ohms. I've got current from the battery out is 12 amps. And I've got the current through D, current traveling through this wire is 2, 4. And this is resistor 1, R1, R2, and R3. So I've got 3 resistors. I need to know what I have, and I do that by filling out my VIR chart. Total voltage of my battery is 12. Total current coming out of my battery is 12. And resistor 2 under resistance is 2 ohms. And then D, which goes through resistor 3, is 4 amps. Oh, this does not look like a ohm. Next thing I'm going to do is I'm going to look through the rows and the columns and see if there is anything that I can fill in because only one is missing. And what's the most obvious one? Well, yeah, you can fill out voltage. The thing about voltage of a parallel circuit is what, Vincent? They're all the same. The voltage drop, because they're all parallel to each other, is going to be the total voltage of the battery. It's going to be 12, 12, and 12. And that's what you can automatically fill in for parallel. Now I can fill in a bunch of stuff because here I have a resistance missing. So VIR, resistance is voltage divided by current. Easy peasy. That's 1. The next one, voltage divided by current. That's 3. And then we've got current this time, which is voltage divided by resistance, and that's 6. Any questions on how I'm filling this in? I'm not going too fast for anyone, am I? Okay. Now, the current in a series, in a parallel circuit, has to split through all the branches. So If I have 12 here, through resistor 2, I have 6 volts going through here, and I have 6 amps going through here, and I have 4 amps going through this last branch. If they all come from this same 12 amp flow, what is my current through R1? It's what?
2.
So 6 plus, yep, perfect. It's whatever's left over. 6 plus 4 plus 2 amps equals 12. So these currents add up to this. Now, I want to look at the resistance. In series, we took the total resistance and set it equal to the total, or we took the sum of the resistors and set it equal to the total. Would that work with parallel? It's not subtraction, but it's definitely reducing. So let's use this method. V and I, if I'm solving for a resistance, is 12 divided by 2. Look at these individual resistors, 6, 2, and 3, but the total resistance is 1. How do you get high resistance values, but then get an equivalent resistance or a total resistance that is less than all those values? We're doing an inverse sum. So here is your total, and we're going to use this as a way of checking. 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3, which ends up being 1 over 6, 1 over 3, 1 over 2, and 1 over 3. Common denominators, 1 6, 3 6, 2 6. And if I add it all together, I get 6 over 6. The answer that you get here is not your final answer, though, even though it looks like it's your final answer. This equals 1 over R total, so I still have to take the inverse of this, 1, and the inverse of 1 is 1. So I just wanted to walk you through the process of calculating total resistance for a parallel circuit, which is a complicated equation. All right. One thing I wanted to emphasize, though, is that when they ask you for the current, this is going to be part of your parallel circuit. The potential difference, your current through E is going to be the sum of your current through C and through D. It's basically this current coming, the 6 amps coming in here, going into E, and the 4 amps coming in here, going into E. So that was the one most students had trouble with. Okay, grab a laptop, start working on the homework. I'll come around and help